On behalf of 24houranswers.com, I welcome you to today's lesson. In this video, this is example 8 to L'Hopital's rule, and we're going to look at the 0 to the 0 power form. We have this function f of x is equal to x to the 2x power, and we want to find the limit as x approaches 0 from the right of f of x. We're going to do all of this pencil and paper, and then we'll come back and verify this in Desmos at the end. And what we're going to do now is something similar to what we did in example 7. We're going to take our function, we're going to take the natural log of both sides, and then we can convert this to an exponential. I've done this right here. If we let y equal x to the 2x power, take the natural log of both sides, we can pull that power down just like I covered in example 7, and then we convert this thing to an exponential. The thing to note here is this. Y is equal to this, and y is equal to all of this. What we want to focus on again, just like example 7, go back and check that out, we want to find the limit of this piece right here as x approaches 0 from the right. And now let's remember, when we find this limit, this is going to be the power that we're going to raise e to ultimately find the limit of f of x as x approaches 0 from the right. So if we let x get close to 0 from the right, well, 2 times 0 is 0. And if we take the natural log of a number that's really close to 0, such as 0.01, notice what's happening. X is getting closer and closer to 0 from the right, and what's going to happen to our natural log is the following. This number is going to get more and more and more negative. So let me come back in here and add a few more zeros. This number here for x, we're talking about the natural log of x, this number here is really close to 0 coming in from the right hand side. Notice we're still getting a negative number here. So as this number gets more and more and more negative, we can say that the natural log of x, as x gets really close to 0 from the right, we can say that this approaches negative infinity. So check out this form that we have here, 0 times infinity or 0 times negative infinity. We've covered that form back in example 5. It's okay that we have a negative infinity here. So here's the trick. We want to rewrite this as a numerator and denominator. So we have the limit as x approaches 0 from the right. I'm going to leave the 2 natural log of x up top, and I'm going to move this x down to the bottom, and I'm going to write it as x to the negative 1 power. Since this was x to the positive 1, we can shoot it down to the bottom and write x to the negative 1. So now let's apply this limit again. If we let x get close to 0 from the right, we've already said that this right here is going to be negative infinity. The 2 doesn't really matter. Over, and now if we take x to the negative 1, well, let's recall that x to the negative 1 is 1 over x. And if we're letting x get close to 0 from the right, we're talking about taking 1 and dividing it by a really small number that's close to 0. Back in example 7, we said something very similar, except we had 3 over x right here, but we did say 3 over a small number that's close to 0. That's no difference really than 1 over a small number close to 0. That is going to be infinity. Check it out. 1 divided by a number that's really close to 0. Check out what we get there. And as I continue to add zeros, this number is going to get bigger and bigger and bigger. Well, this is great news because now our form is infinity over infinity. In example 3, we covered that form, and now we can apply L'Hopital's rule. So therefore, if we find the limit now as x gets close to 0 from the right, let's take the derivative of the top, which is going to be 2 times 1 over x. All I did there was take the derivative of natural log, and the derivative of the bottom is going to be negative 1x to the negative 2. Pulling the power down and then subtracting 1 from the exponent. If we clean this up a little bit, we're going to have 2x to the negative 1 power. That's what 1 over x is. And this is going to be over negative 1x to the negative 2. I'm going to write x to the negative 2, and I'm just going to stick that negative up top. This is just cleaning it up a little bit. And now, finally, if we take this x to the negative 2 and we shoot this up to the top, it will become negative 2 x to the negative 1 times x squared, shooting that negative exponent up top. And then finally, if we add our exponents, we will have the following limit. The limit as x gets close to 0 from the right of negative 2x, and then if we take negative 1 plus 2, that's just going to be to the positive 1 power. Now if we let x get close to 0, from the right, -2 times 0 is pretty much 0. But let's remember, this right here is the limit of this piece to find the limit of f of x. As x gets close to 0, from the right, we take e and we raise it to whatever we got for this limit, which was essentially our exponent here. So we're coming back and taking that limit and we're saying e to the 0 power, our final answer is 1. Let's verify this over in Desmos. Here's the function, x to the 2x power. As we get close to 0, coming in from the right-hand side, notice I'm getting closer to 0. Right now my x value is 0.06. Our y value is 0.713. And I tell you what I'm going to do. I'm going to zoom in here so we can get real close to 0. And I do want you to see that that y value is getting closer and closer and closer to 1. I mean, check that out. When x is 0.001, the y value is 0.9863. Hence, as x gets close to 0 from the right-hand side, our function does approach a y value of 1. And there you have it, the 0 to the 0 form for L'Hopital's rule. Very similar to example 7 in the fact that we're finding a limit, but that's not going to be our final answer. We want to take e and raise it to that power to get our final answer. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.